In the last video, we talked about what limits are and how to evaluate some of them algebraically. But before we move on to any complex limits, we should go over some properties of limits. Let's say we have the limit as x approaches a of some function f of x, and it's equal to 2. And let's also say we have the limit as x approaches a of some function g of x, and it's equal to 4. Let's say we're asked to find the limit as x approaches a of 3 times f of x. By the properties of limits, we can take out the 3 as a multiple. So it becomes 3 times the limit as x approaches a of f of x. And we know the limit as x approaches a of f of x is equal to 2. So we can substitute it. So it's equal to 3 times 2, or 6. Let's now say we were asked to find the limit as x approaches a of 3 times f of x plus 4 times g of x. By the properties of limits, we can separate this into two limits. So it will become the limit as x approaches a of 3 times f of x plus the limit as x approaches a of 4 times g of x. And from before, we can use the same property by taking out the constant multiple, and it becomes 3 times the limit as x approaches a of f of x plus 4 times the limit as x approaches a of g of x. And again, we can substitute it, so it becomes 3 times 2 plus 4 times 4 from up here. And so this will be 6 plus 16, which is equal to 24. Let's say we were asked to find the limit as x approaches a of f of x times g of x. By the properties of limits, we can again separate this into two multiples. So it will become the limit as x approaches a of f of x times the limit as x approaches a of g of x. And again, we can substitute it. It becomes 2 times 4, or 8. Now, let's try the limit as x approaches a of f of x over g of x. We can rewrite a division statement as a multiplication simply by taking the multiple of the reciprocal of g of x. And so now these two will be equal. And so again, using the property of multiplication, we can separate it. So it'll be the limit as x approaches a of f of x times the limit as x approaches a of 1 over g of x. And so, again, we can substitute. This will be 2, and this will be 1 over 4, and so it'll be 2 over 4, or 1/2. Let's try something a little bit more complicated. Let's find the limit as x approaches a of 3 times g of x cubed plus 4 times the square root of f of x. So again, we have an addition, so we can separate it. So it will become the limit as x approaches a of 3 times g of x cubed plus the limit as x approaches a of 4 times the square root of f of x. We have an exponent here, and technically we have a square root here, which is just the exponent of 1/2. Exponents are just repeated multiplication, so really we can just use the same multiplication rule. So let's take out the constant multiples first. So it'll be 3 times, and here we use the multiplication rule, the limit as x approaches a of g of x, and it will just be cubed. And similarly, it'll be 4 times the limit as x approaches a of f of x squared all over the square root. And so again, we can substitute. It'll be 3 times 4 cubed plus 4 times the square root of 2. And so this won't be a nice number, but it will be 3 times 4 cubed. 64 is that? Yeah. Plus 4 root 2. And you can put that on your calculator, but I'm just going to leave it as that. Those are all the basic limits of properties. And so we should be able to move on to more complicated limits.